Hello, welcome to my channel. My name is Fran, and today I would like to talk about the link between quantum physics and the law of assumption, and why I'm deeply convinced that both tell us the same thing but using different language. Now, those quantum physicists who will disagree with this statement are the ones who reply to quantum physics findings by saying that they don't know what they mean, but meaning is not what they're after. For lack of better words, meaning means nothing to them. There are those who think quantum physics works in practical applications such as transistors, lasers, smartphones, and so on and so forth. It's the most reliable physical theory we have at the moment, yet we don't like the theoretical implications of it, as they sound too esoteric, and most of all because they imply that observation creates that which is observed, which sounds way too much like magic or religion, and also makes the role of the scientist as we know it a bit redundant. So let's rephrase this. If we all create reality through observation, then the scientists claim that his or her observation is somewhat superior or more accurate or more real than yours is an illusion at best. This is why quantum physics made these discoveries a century ago, over a century ago, in fact, but the scientific establishment has been incredibly quiet about it. The only time you hear about these esoteric properties of reality and of quantum physics is on YouTube or other social media. But this is not because scientists don't agree with the weirdness of quantum physics. It's because they cannot explain it in view of their existing paradigm. Quantum physics doesn't agree with a belief system, which paradoxically is not a very scientific approach to take. There are some scientists, however, who lift their heads from the calculations and ask themselves what those calculations actually mean. They put knowledge and imagination together. They suspend what they have known up until now and see what this could mean. A bit like Einstein did when he challenged Isaac Newton's and his law of gravity and motion. One of these scientists is physicist David Deutsch. According to Deutsch, the ultimate aim of science is to find meaning, to understand how life works and why. It's not sufficient to use science for practical applications. The reason that the scientist does what she does is to understand the game of life. And I don't use the word game by chance. You see, Deutsch looks at the latest discoveries in quantum physics and information technology, and then draws an invisible line between the two. The question he asks is, could reality be a virtual reality simulation type thing? How does reality as we know it resemble a virtual reality game? Deutsch also challenges the belief or common sense notion that the future resembles the past. It challenges the concept of induction, or that you can predict the future from past experience and observation, because you can never rule out the exception to the rule. And quantum physics tells us that the exception is real. You just cannot predict when it will happen. For instance, thermodynamics tells us that entropy always increases within a closed system. Now, entropy is the degree of chaos in a system or the degree of disorder. For instance, if you pour milk into a coffee, we can be pretty sure that the two will mix, creating more disorder as the molecules of the milk and the coffee intermingle. We can also predict quite reliably that they will not separate again. Yet quantum physics predicts that if you lived forever and if you waited long enough, eventually that will happen. You just cannot predict when. The best quantum physics can give you is a probability. So that's the best it can do. Now, in extremely rare cases, entropy will decrease. It is just incredibly unlikely that on the human scale, this will happen within an individual's lifetime. Also, how do you know that we live in a closed system? We don't. As far as we can tell, we live in an infinite multiverse. And how can you define that, a closed system? But why have I told you all this? Let's go back to the beginning, because scientists like Deutsch realized that the predictive value of science rests not in induction, but the basically from the fact that we can predict the future from our past experience, but rather in argument and simplicity. In other words, a scientific theory is more valid than another if it accounts for reality in a more reliable but also simpler, less complex way. It doesn't matter how outlandish its predictions are. They don't have to agree with common sense or be consistent with what we have observed in the past, as long as they offer an explanation that is consistent with the equations which work in practical applications, and as long as that explanation is the simplest amongst those existing. That has to be the best explanation at present. And then Deutsch offers what, according to him, is the best available explanation, that we might live in a simulation. It's sort of Truman Show or Matrix, if you prefer Keanu Reeves to Jim Carrey. So how does he justify this hypothesis? First, it starts from a version of the double slit experiment. Now, if you're not familiar with the double slit experiment, I will put a link of my video about it in the description below. But to sum it up, Thomas Young was the first to propose this experiment in 1805. Since then, it has been replicated over and over again, and its findings are not disputable. Basically, in this experiment, a light beam is aimed at a screen with two open slits in it, one next to the other. And at the back, there is another screen. This is where the particles land, so to speak. Now, we are talking about light, so we are using photons as an example. However, the experiment has been carried out using many different subatomic particles, including electrons, which are considered the building blocks of matter. And all these particles behave exactly in the same way. So when we aim the beam of light towards the screen, we expect to see two bright lines to show up in the screen behind, in correspondence with the two open slits. Instead, what we do find is an interference pattern of bright and dark lines all over the second screen, pretty much like you would find if water was passing through the slits. In other words, we see waves, not particles. And this applies equally to light, to photons or electron, to light or matter. Now, what is so confusing about this is that at first, scientists thought that particles were hitting the side of the slit, bouncing off them and interfering with each other. So they tried to observe what was happening to the particles mid-air, so to speak. They wanted to see the actual journey they took, and so they placed sensors just after the slits to see what was really happening. This is when they had their first shock. What they observed was particles behaving not like waves, but as actual particles. So the interference pattern disappeared, and in its place were the two bright lines that they were initially expecting. Boom. When you observe the particles that make up matter, they stopped behaving like waves and resumed the particle identity. Now, I use the term identity not lightly, but because particles appear to have some sort of consciousness or knowledge of the fact that you are observing them. Now you can see why the majority of quantum physicists have trouble with interpreting these experimental results and reply with, shut up and calculate. In other words, don't worry your pretty little head with questions of meaning and philosophical assumptions. Matter with consciousness? Surely not. Now, let's go a little bit further. So when electrons, say, behave like particles, which slit do they really go through? It appears that by repeating the experiment over and over again, they go through each slit at random with roughly 50% chance. If you increase the slits, the chance of the particle going through each slit is proportionally reduced. For instance, if you try the same experiment with 4 slits, the chances of the particle going through each slit is roughly 25%. Now, the realist has 3 problems. Number 1, matter behaves like a wave. Number 2, it goes back to behaving like a particle when it's being watched. Number 3, its behavior cannot be predicted. You can only get the probability of it being in one place or another, and the highest probability you get is 50%. Basically, going through one or the other slit appears to be completely random. So the scientists had to contend with the fact that matter changes its behavior when it's being observed, which is weird in itself. But then you have to try and define what counts as observation. And as it turns out, that is not so straightforward either. Then they have to contend with this randomness that you cannot infer the future behavior of particles beyond the 50% chance cutoff point. It appears to be absolutely random. I say appears because I have my own idea, which happens to agree with Neville Goddard's view of reality, that the behavior of matter is not random when you take into account the expectations of the observer. Now you see why the modern scientist has a problem with interpreting experimental results in quantum physics. All of a sudden, you find yourself in metaphysical territory. You simply cannot interpret these findings by using your existing paradigms about reality. You are expecting this stable, predictable world, and instead you find yourself confronted by a malleable reality which changes when it's being observed. Now, let's go back to Deutsch's interpretation of the slits interference experiment. Let's see how he interprets the findings that many of his colleagues refuse to interpret at all. He says that the truth of the matter, pardon the pun, is inescapable. But what is it? Let's see if I can simplify his interpretation. When particles are shot one at a time towards the slit and no detector is placed by the slits in the screen, they still behave like waves. Let me rephrase these. Even when there is only one particle of matter, it interferes with itself and behaves like a wave. At first, scientists thought that it might split up and reunite after the slit to give the impression of a wave. But when they placed the detectors by the slit, they found out that, as we have seen, the particle always goes through just one slit. So how can it interfere with itself? According to Deutsch, there is only one possible explanation. If the observed particle only ever goes through one slit at a time, when observed, then there must be what he calls shadow particles, or virtual particles, if you like, which mimics the observed particle, but which goes through a different slit. The more slits you have, the lower your ability to know the probability of your real or tangible particle going through one or the other slit. When unobserved, when the sensors are not there after the slits, the probabilities are wide open, and your ability to localize your one true particle is extremely low. It could be anywhere. But what Deutsch says about the virtual photons is even more interesting. He says that although we do not see them, and never will, even with the most advanced technological tools, they do have a real effect on the particles that we do see. There is no denying this fact, and if something you don't see has a physical, real effect on something that you do see, then by definition, that invisible something must be real. For instance, you don't see radio waves, microwaves, Wi-Fi, or infrared light. You only see their effects. Therefore, you must conclude that they are real. And nobody disputes these. For Deutsch, and for anyone thinking logically, this can only ever mean one thing. Those virtual particles represent real alternative realities in which our real photon appears virtual, or appears to be a shadow of their real tangible photon. Period. There is no alternative explanation. We live in a multiverse, and even though we cannot see them, there are copies of ourselves in adjacent universes, maybe infinitely many. And the reason we don't see them is that there are restrictions inherent to this reality which limit the information that we can access, namely the laws of physics. Yet, by the power of argument, we can infer their existence beyond a shadow of a doubt. Deductive reasoning inexorably leads us to this conclusion. We live in a multiverse, the so-called many worlds interpretation proposed by Hugh Everett, in which many copies of us live a different life. We are affected and we affect some of them, but which ones? That depends where we choose to place the slit and where we decide to place the detector. Each slit will have its own shadow particle. Or in other words, each observation will bring to life a different reality. So this takes us right into the arms of Neville Goddard and his law of assumption, according to which to imagine is to create. God is imagination. And what is imagination if not a form of internal observation? As we have seen from psychology, the subconscious mind cannot tell the difference between what is imagined and what is real. Wow. Now let's think about this for a second. The subconscious mind is our reptilian brain, the part of the brain that was developed earlier in the history of human evolution. The ancient part of the brain, the one that kicks in and takes over when our lives are in danger. The one that acts quickly below the level of awareness, the one that allows us to carry out complex skills in automatic mode. And that part doesn't know the difference between real and imagined. Now, if it were so important to know the difference between the two, if that enabled survival, you would have thought that it would have developed earlier. Yet only the conscious mind can tell the difference between the two. When you dream, you don't know that you're dreaming, do you? The dream feels real to you. So the demarcation line between real and imagined seems to become more and more blurred. Our subconscious mind, the one that never sleeps, the one in charge of keeping us alive, doesn't know what is real and what is imagined. So quantum physics says that when we open just two slits in the first screen, we have the greatest chance of observing the particle going through one or the other, one of those slits. Other experiments, for example, the Daryl-Bem experiment, showed unequivocally that when you used human observers, the observations seemed to align with participants' expectations above the level of pure chance. It was therefore proven statistically that the participants' expectations affected the outcome in the expected direction. So there you have it. We've come full circle to Neville Goddard law of assumption. You expect a certain outcome subconsciously, then you are more likely to observe it in reality. I say subconsciously because that is the part of the brain that cannot distinguish between what's real and what's imagined, as we've seen. So if you hope for something to happen, or if you repeat something to yourself, but you consciously resist it, if you try to convince yourself that you can have something, but deep down you think it's impossible, then that's the conscious part of the brain in action. And that does not connect you with any alternative reality. It just keeps you grounded in this one. So we've come back to Neville Goddard with creation is already finished. You are not creating anything new. Creation is finished. You simply shift from one reality to an adjacent reality by observing or imagining it as real. In this way, you can explain quantum physics findings. You can explain what people call precognition, which is just the preview of an alternative reality accessed by the subconscious mind. You can even explain near-death experiences. All this weirdness simply vanishes when you take into account these alternative realities that can be accessed through our subconscious mind. It becomes clear then that everything that we experience in this 3D physical world is simply an illusion rendered by our five senses. I've used this term rendered, which is a virtual reality term, on purpose, because what you think is real can in principle be rendered or recreated by complex computers. And there is nothing in science today and in the laws of physics that says that we do not live in a complex simulation type reality. And since we cannot rule it out, then it must be our assumption until new evidence emerges which allows us to rule it out. At present, this is our best explanation for how reality works when we take into account the latest findings in quantum physics. Neville Goddard put it in a more spiritual way, having probably little or no knowledge of quantum physics. when he said that there is only one consciousness, and that it split itself up into many observers so that it could know or experience itself from many different perspectives. And how was this delusion of separateness created? Through imagination. And we are back to God. According to Goddard, God is our imagination. Imagination is observation of something that we can envision within, but which is not yet hardened into fact, not yet experienced with our five senses. In other words, we are delusional not when we imagine something which in the 3D world may appear impossible, but rather when we bind to the incredibly powerful illusion of the physical reality which we experience through our sense organs. So when you are trying to access an alternative or shadow reality, you simply have to suspend your rational mind, the conscious part of the brain, and allow your subconscious mind to contemplate the possibility of its existence. You let consciousness or awareness take you to that preferred alternative reality. Of course, this latter part, this conclusion, cannot be scientifically proven yet. Maybe it will never be proven by science as we know it today, unless perhaps we can bring ourselves to imagine that scenario, a scenario in which we can scientifically prove the existence of alternative realities. Now, let's consider this hypothesis. What if reality experienced through our five senses is an illusion, and the only thing real is imagination? If imagination changes what we experience, then imagination must come before reality. We define something as real because we can perceive it with our senses. If we kick a rock, we can feel the pain and may even break some bones. So we conclude that it must be real. The rock is real. But high-tech reality simulations can easily reproduce sensations that seem absolutely real. 3D images, sounds, touch, smells, and taste. In fact, neuroscientists tell us that you can reproduce any of these real sensations simply by stimulating the right centers in the brain. Phantom limbs are a common occurrence in amputees. In other words, people who have lost a limb can still feel sensations such as pain or itching in the amputated, say, foot, for instance. A foot that is no longer there, but whose cerebral area is still intact. So the limb still exists in the person's nervous system and it feels absolutely real, yet it's no longer there. So you see, our senses are in no way a reliable source of evidence when trying to decide whether something is real or is not. What emerges from all these different disciplines is pretty clear. Establishing what is real is not so straightforward, but what is straightforward is this. What we observe changes when observed. The future doesn't necessarily resemble the past. There are many alternative realities and they are all real. But you can only ever be aware of one of them at a time. Our awareness is the link between these parallel realities. We can consciously choose which one to experience by impressing and reprogramming our subconscious mind. If you observe something as if it were real, then it is real, and eventually you will see it out there reflected onto the screen of space in the illusory 3D. Reality is an illusion. The only real thing is imagination. Now, most scientists might disagree with this outlandish statement, but one thing that they will not disagree with is the soundness of the scientific method. If you want to know if a theory is valid, then put it to the test. Imagine something is real and know that it is real. It is real. Then go about your life as usual. Let go of all disbelief. Surrender to the process. Keep an open mind, just like a scientist who has to prove or disprove a hypothesis. Be open to the possibility, stay neutral, and see what shows up in your life. But be prepared to witness the impossible. So this is it for today. I intend that this content will help you see past the illusion of the present reality and manifest the life you really desire. If you found this content interesting and helpful or thought-provoking, please remember to like, share, and subscribe. In any case, thank you for listening. Have a wonderful, awakened day.